We know that here on Earth, if you were to take a source of light, like a flashlight, and move it farther and farther away, it will get dimmer and dimmer. Knowing that, what would you tell me if I asked you why another source of light, the same distance away, appears to be much brighter than the dimmer one? Logically, you'd probably say that it must be a more powerful and luminous flashlight that is emitting the light, and you'd be right. In the very distant reaches of space, we sometimes see very bright objects despite the fact that they are extremely far away. These objects, the extremely luminous centers of the farthest galaxies, are called quasars. Quasars are small yet very powerful sources of energy. That is why they appear so bright to us despite their distance. That is why they drown out the light of stars in the galaxy at whose center they sit in. The energy they release also produces a ton of visible light, which accounts for what I just said about them. A galaxy whose center emits a vast amount of energy is called an active galaxy, and the centers of active galaxies are called active galactic nuclei, or AGNs. You can think of quasars as one type of active galactic nucleus. Astronomers believe that in the centers of active galaxies are supermassive black holes. Matter swirls around these supermassive black holes in a disk called an accretion disk before plunging in. As this process occurs, a lot of energy is released. If you watched the lesson on supermassive black holes, you're probably thinking, so what? Don't most galaxies contain supermassive black holes at their center? Why isn't our own galaxy releasing a ton of energy akin to active galactic nuclei? Well, most galaxies do in fact contain supermassive black holes in their centers, but the black holes at their centers need not be active. Instead, they can be dormant, like a dormant volcano isn't active. In such cases, these dormant supermassive black holes rarely swallow up anything that enters too close because they already did that long ago and there's not much stuff nearby to swallow up anymore. That's the case with the Milky Way galaxy today. Hence, active galaxies are normal galaxies that are simply going through a developmental phase many galaxies go through. In the intro, I mentioned that a light that appears brighter is more powerful. You'd also expect it to be larger. However, the powerful active galactic nuclei are quite small in volume. The way astronomers have ascertained this is actually pretty cool. Firstly, astronomers have observed that active galactic nuclei are variable, meaning their brightness changes over time. That's the first clue. The second clue is that they flicker very quickly. Let's put these clues together to find out why they occupy a pretty small volume of space as a result. Carefully study the diagram on your screen as we do this. Imagine that there is an object out in space that is 1 light year across. All of a sudden, it emits a very brief flash of light. The photons that are nearest to Earth will reach an astronomer's telescope first. Photons from the middle of the object will reach the telescope in 6 months. And photons from the most distant edge of the object will arrive 1 year after the first ones arrived. This means that we see a gradual increase in brightness of this object for a full year because an object cannot vary in brightness any faster than the length of time it takes light to travel across that object. Okay, now that we've got that down, I have to tell you something. Active galactic nuclei can undergo fluctuations in brightness in as little as a few hours. Therefore, astronomers have realized that active galactic nuclei must emit their energy from a small volume of space. It's estimated to be a region no larger than that of our solar system. But who cares, right? Actually, it is pretty cool that this is the case because such a relatively small region of space emits more energy per second than 1,000 clearly much larger galaxies. The extremely luminous centers of the farthest galaxies are called quasars. Quasars are a type of active galactic nucleus. Active galactic nuclei are the centers of active galaxies, and an active galaxy is a galaxy whose center emits a vast amount of energy. Astronomers believe supermassive black holes at the centers of active galaxies may be responsible for the release of such large amounts of energy. This lesson should have taught you one other very important point. That is the fact that active galactic nuclei, despite their enormous brightness, are actually confined to a relatively small region of space, smaller than that of our solar system. Astronomers were able to figure this out by observing how long it takes these objects to vary in brightness over time.